All right, so the notes that we are doing, are you guys ready? But are we ready? All right, so the notes that we are doing is we are finding out how to integrate logs, are you ready? Logs and exponents. Logs and exponents. It's going to be so fun. No. You guys look way sadder than you should be right now. You should be really happy about this. No? Nope, not feeling it. Okay, so we have 3 little shortcuts, rules, that we're going to be using. All right. So the first one is the integral of 1 over x dx is ln of x plus c. And the x is in absolute value signs because you can't take the log, right? Ln is log. Do you guys remember what the base of it is? E. It's log base e, good. You can't take the log of a negative number, so we are forcing that to be positive by putting an absolute value sign. So no matter what you plug in for x, it's going to have to be positive for you to be able to ln it. So hopefully you guys kind of remember that when we took derivatives. If you needed to take the derivative of ln, it was 1 over x. You guys remember that? Yep. So, yeah, so that's, now when we go backwards, if we see a 1 over x, we're going to be like, oh yeah, that's ln x, because we went backwards. Hey, Pat. The next one is e to the x. Do you guys remember what we could have taken the derivative of that would have given us the derivative, e to the x? I think somebody said it. It's e to the x, yeah. The derivative of e to the x was itself. So when you integrate e to the x, it's going to be the same way. So isn't that fun? And then we got one more. We have a to the x dx, where a is a number, so it could be like 2 to the x or 4 to the x. And this antiderivative is going to be a to the x divided by ln a plus c. So those are the 3 rules that we're going to use today. And if you guys remember this, these weren't always straightforward to find the derivative of. What often happened when you did find the derivative? What did we have to remember to do? Chain rule. Chain rule happened all the time on these. So now that we're doing antiderivatives for these, what do you think is going to happen as we do the integral? We're not the chain rule, but how do we reverse the chain rule? What do we call it? U-Substitution. We're going to use U-Substitution a bunch on these. So disgusting. This is terrible, Ms. Rice, I hate you. Okay, examples. We're going to integrate each of the following. Yay. So the instructions are to integrate. I'm so happy that you guys love these so much.
Yeah. Integrate.
Yeah. So, are you guys listening? Now, before when we did U-Substitution, we would look for like the inside of the function and the outside of the function, and I think that it was reasonably easy. Maybe easy is not the right word, but it was okay to like figure out the inside and the outside. These ones are going to be a little bit harder to tell because our outside function might be 1 over x, which is not like the same as like, oh, it's to the 5th power, so the 5th power is the outside function. It's not quite so easy to be able to see that this time. So hopefully as we do more of these, you'll be able to recognize which one it is, but it may not be obvious right away. And honestly, the best way to get better at these is just to do lots and lots of them, because then you'll start to be like, oh, I can see what that one is. I've done that 5 times already. Does that make sense? It may not be like I can tell you a straight answer about how I recognize it. The reason I can recognize it is just because I've made a bunch of answer keys at this point, so I've done a bunch of these. Does that make sense? Yes. Okay. So for this one, I'm just going to start off by kind of telling you what the inside and the outside is, or how we're going to do the U-Substitution, and hopefully you guys will start to pick up how we can make that happen. So for this one, the u is going to be the bottom of the fraction. So we're going to say u is x squared plus 1 And if that is u, then what should the du be? 2x dx, right? And I can see the x on the top of the fraction, but what are we missing? 2. We're missing the 2, so I know that I'm going to have to divide this by 2 because it's not in there. So the thing that I am actually integrating is 1/2 of, and do you guys know what we're actually integrating? 1 over u, yeah, good. 1 over u du. And so, and the reason I could see that is because I took the bottom and I made that u, so I know that u is going to be on the bottom, and that x was the same as the x for my derivative. So that's why I kind of ignored the x on the top, and then the dx is part of the dx for my du. All right, so at this point now we're going to look up and we're going to see which one does this go with, the first, the second, or the third? The first. So this is going to be 1/2 ln of u plus c. And what should I put inside the absolute value sign? X squared plus 1. So I've got 1/2 ln of x squared plus 1 plus c. No, I'm good. Wait, what does it say?
It says miles to class at 2:31 on December 5th.
Does it say excused or unexcused?
Say what?
Does it say excused or unexcused?
Oh no, it was from my teacher from my last period, but she didn't have an actual message. She wrote it on the back.
Oh, okay. Oh, okay. I got you.
So honestly.
All right. How do we feel about that problem? Was that okay?
Actually,
Yeah. Yeah, I mean, of course they get worse. They can't stay easy. Okay. Let's look at the next one.
Oh, that's the absolute value sign?
Yes.
I
And
put 1,000.
yeah, that's an absolute value sign. Sorry, my 1 was real long. That's just a 1. Does that look better? Is that easier to read? Okay. For the next one, we're going to evaluate the integral from 1 to e of ln x over x dx. Sorry, I was very zoomed out. There you go. So, now this one, even though I was kind of rusty, I was able to see this one. Because remember, Brandon, when we do U-Substitution, we want to be able to see something that stands for u, and we want to be able to see its derivative in the same problem. So can you guys see what u is and what the derivative of u would be? Yeah, u is ln x, and then what is du? 1 over x, yeah. So can you see where those are in the problem?
Yeah.
So the ln x is on top, and then that means that if we were to take that ln x off of the top, then what's left over in the problem is 1 over x. So we can see the function is here and its derivative is there perfectly. We don't need to add anything in there. You guys see that? Mm-hmm. And then the dx, yes. Yeah. Okay. So when we go ahead and integrate this one, we're going to be integrating what? Not 1 over u, just plain old, yeah, u over 1 or just u, right? Yeah. And du. Okay. Now, we did one of these before. Do you guys remember how we did this before where we said, I can't put the letters, or the numbers, I can't put the numbers in here because this is in terms of u and this original one was in terms of x? You guys remember that? So how do we take these numbers and fix them so that they're in terms of u instead of being in terms of x? Plug it in, yeah. So u equals ln x. So for the first one, I'm going to say the first u is going to be if I do ln of e, and the second u that I'm evaluating is going to be if I did ln of 1. So can someone tell me what ln of e is? Ln of e? You can type it in on your calculator. Ln of e, ln of 1. It's 1. So since an e was on the top, we're going to put a 1 on the top. We're going to do a few like this, and I'm going to keep showing you how to do it so you can pick it up, because I think it was confusing the first time we did it, and I think it's important that you guys can do it with the U or with the X. Then when we plug in 1, what do we get? ln 1. 0, good. Okay. All right, so if I integrate this, what do I get? Just plain old U, that's what I'm integrating. Yeah, so I get 1/2 U to the second power, and I'm evaluating that from 1 to 0. Okay. So that's if I evaluate the U version. If I go back and I replace the U with what I know that U stands for, then I would have 1/2 of ln x to the second power, and this one, since this one's in terms of x, I could evaluate this from e to 1. These two things are the same. They're identical. You should get the same answer regardless of how you do it. Okay? So last unit, when I first showed you how to do this, you guys were more comfortable with plugging the x back in and just doing terms of x the whole time. But I want us to practice this so that we can do the u's instead, if we need to. Okay? So if we do the u's, we're going to say 1/2 times 1 squared minus 1/2 times 0 squared. And what do you get? You get 1/2. And if we had done this in terms of the x's, just like we did when we were finishing up last unit, then we would have had 1/2 of ln e squared minus 1/2 of ln 1 squared. And what was ln e? It was 1. So do you guys see how that's the same problem? What was ln 1? 0. So ultimately, it doesn't really matter how you do it. You're still going to get the same answer. The only issue would be, the reason I want you guys to be able to do it, evaluating it in terms of x's or evaluating it in terms of u, is because sometimes you're not going to have the ability to plug the x back in and evaluate it that way. Sometimes you're going to have to evaluate it using u, and I want you guys to be able to do that. And that actually, on the test yesterday, there was a bonus question where you could only do the bonus question if you knew how to do this. If you didn't know how to do that, you couldn't have gotten it. Yeah. And that's what made me realize, well, I saw that question, I was like, oh, they need to definitely, I'd shown it to you guys once, but I wanted to make sure that we go back so that we can feel comfortable with this process. So how do you guys feel about evaluating the U? Can we do that? It's not too bad. You just have to remember it. You just have to be careful. Okay. That was example number 2. We're going to move on to number 3. So this one we're going to go back to indefinite. So we're going to evaluate x squared e to the x to the third dx. And we want to see if we can recognize what u should be and what the derivative of u would be. Yeah, e to the, I don't know if I would say e to the x, because the derivative of e to the x is another e to the x, right? So we'd have to see 2 of them in the problem.
So it would just be x cubed.
X cubed, yeah. So we'll repeat that line of thinking. So if we wanted u to be e to the x, then we would have had to see another e to the x in the problem for it to be its derivative. And we didn't see that. So that means that the u would have had to be just the exponent. What's the derivative of u? 3x squared dx. Do we see 3x squared in the problem? No. You see the x squared but not the 3, so that means we got to divide by 3. 1/3, what did we say? E to the u du. And then if we look back up at our notes, what's the antiderivative of e to the u? E to the u plus c. So we've got 1/3 e to the u plus c. And then what do I do? Yeah, plug in x to the third. So this is 1/3 e to the x to the third plus c. Fun? Not fun? Fun? Not fun? Not fun? Have you guys noticed we've switched away from derivatives to integrating?
I like derivatives.
Yeah. But you guys were so excited to get away from derivatives.
I like derivatives.
But now you're not excited. Now we want derivatives
Are
back.
we going to be excited to get away
Our
from
first love.
integrals?
I don't know that we're ever really gonna get away from it.
Well, you talking about AB or in BC2?
You guys know I don't look that far ahead. We're gonna be on integrals for a while. All right. Here's the. You're asking me questions I don't know the answer to.
Hey, y'all talking about
You might have to jump there. Take some of that.
All right. Here is the next one.
Oh, I thought you had to do this.
Probably negative 3x.
I don't even know where you're at.
I don't know what we're learning the day after tomorrow. Yeah, you can put it in there. I know what we're learning tomorrow though.
No, that's not
It's
always
always
This is cool. He used to do the lesson plans like right before the class. Like, he read the book right before class. Like just learn what he was doing and then teach it. He wouldn't teach it. He gives us more. He would read the book at lunch and then like teach 4th grade.
All right. So I've never done that today. Just before this class, earlier this period. So for this one, can you guys recognize what U would be? Negative 3x.
I got it this time.
Yeah. And what's du? Negative 3 dx. And do we see the negative 3 there? Nope. So we don't see. We see the negative 3 from the u.
Yeah.
We don't see it from the derivative. So that means that we've got a negative 1/3 in the front, and we're taking the integral of, what are we taking the integral of? E to the u du. And let's go ahead and we're going to figure out how to evaluate this. So our original numbers were 1 and 0. So I'm going to say u equals negative 3 times 1. What's that? Negative 3. So negative 3 goes where the 1 was. And then we've got u equals negative 3 times 0, which is 0. I'm going to put the 0 where the 0 was. Do I have to fix the numbers because they're backwards? No, I do not. The answer, yep, they correspond to the numbers that we plugged in. The answer is going to work itself out. Okay, so when we take the integral of this, what do we get? E to the u. And we got that negative 1/3, right? Negative 1/3 e to the u. And should we put a plus c? No. Why not? It's definite. We're evaluating it. Okay. Okay. Should I take the u and plug the negative 3x back into it? No. Why? But why not? Because we changed the numbers that we were plugging in to correspond to u. That's for u, not x. Yeah. So if you did put the negative 3x back in, then you should be evaluating it with the 1 and the 0. But we changed it, so we're going to go ahead and use the u. So I've got 1/3 e to the negative 3 minus, oh, and that was a negative 1/3. You can't see it very well because my negative went with my fraction. Okay, so negative 1/3 e to the negative 3 minus negative 1/3 e to the 0. And what does that give us if we simplify it? Well, okay, I'll make it easier for you a little bit. This first part's going to stay the same. We'll leave that. Minus minus makes a plus. And why'd you say 1/3? Where'd the e go? Anything to the 0 is a 1 power. Except for 0. 0 to the 0 is not 1. And that right there is an E, not a C. Right there, that's an E. Whew. Next one. We ready?
No. Stop it.
All right. So we haven't done one of these yet. So let's compare it with the little formulas we have, or the little shortcuts we have. Which one does it look like? A to the x. Does it look like it is one of the ones that uses, or that used the chain rule to get there? Did it use the chain rule? It matches this exactly. It's 2 to the x dx, and so that means the a is 2. So this one is a very straightforward problem. There was no chain rule in the problem. It's just, it goes straight to the other one. So if we had 2 to the x dx, then what's our answer going to be for our antiderivative? 2 to the x over ln 2. Okay. So we have 2 to the x over ln 2. Do we want to put the plus c?
You don't have to.
We don't have to because it's defined. It's a definite integral. We are evaluating it from 5 to 0. All right. So what should I do next? Plug the numbers in. So I have 2 to the 5 over ln 2 minus 2 to the 0 over ln 2 equals, of these two fractions, I have a common denominator, right? So ln 2. And what do I have on the top? I've got, what's 2 to the 5th? 64. I think it's 32. 2 to the 5th, 32?
Yeah, 32.
It's 32. So we've got 32 minus 1 is 30. Did we say it? 31? 31. My fraction was a little overkill there. Too big. 31. 31 over ln 2. How could we check our answer on this one? Yeah, you could type this in the calculator and then type that in the calculator. Make sure your decimals match, right? We could do that. Okay. Number 6.
Oh my god.
There are 7 examples. If it was the video, I would have done like 5 on the video and then done 2 in class today, but you know. All right. For this one, we are going to say we've got 3 to the x over 1 plus 3 to the x dx. And this one's going to be a little bit more difficult for us because I think this is probably using a rule that you don't remember very well. So, does anyone have their little yellow sheet? Let me... he didn't just say that's gone with the wind.
Oh, I know what he said, but
He used another noun in there.
I got it, but it's on my vowels.
That was not the book title. The book title was just Gone with the Wind.
we haven't done funny videos in a while.
I'm gonna have to remake this video. All right, so you guys. All right, so on this one, we're going to say that u is 1 plus 3 to the x. And the part that I think that we're going to maybe be a little bit rusty on is finding the derivative of 1 plus 3 to the x. And so that's where the yellow sheet comes in handy. So this right here was the rule for the derivative of that. So the derivative of 3 to the x should be what? 3 to the x ln 3. Okay. So I'm going to say that the derivative of u is 3 to the x ln 3 dx. And I can see some of that in the problem, but not all of it. What's missing? The ln 3. So this is a decimal. ln 3 is a decimal. It's a number like we've done before. So we're just going to say, all right, divide by ln 3 like we usually do. It's going to be not quite as nice of a number as it usually is, but it still works out the same. And so that means that the problem that we are doing is we have 1 over ln3. And then what is it that we're integrating now that we're using the u's? 1 over u du. Okay? And do you guys remember what 1 over u becomes? ln u. Yeah, good job. So we have 1 over ln3 in the front multiplied by ln u plus c. And what should I do next? So 1 over ln3, ln, and inside the ln I've got 1 plus 3 to the x plus c. So you can leave the answer like that, or if that 1 over ln3 makes you uncomfortable, you can just put it on the bottom. So you can say ln of 1 plus 3 to the x over ln3 plus c.
I don't even know which, like...
So it was just like some of the ones where we had like 2 to the x and the 2 didn't show up, so we called it 1/2. The only difference is our number is not as comfortable to us, but the problem works the same. Yeah, it's a messy looking answer, right?
I never ever.
God.
I walked into a math 3 class when I looked at Bryce's paper, I was like, I don't know how to do that. I'm doing regular laws.
It's just so aggressive. God.
All right, last one. Are you guys ready? And then we practice. Okay, so we are going to find the integral of tan x dx. It makes me so sad that you guys dislike it so much. All right, do we remember when we were taking derivatives? Is there something you take a derivative of and it goes straight to tan? No, there's not. So that means that since we don't know what it was that went straight to tan, that this problem we're at like a dead end if we leave it looking like this. So what's another way you could phrase tan?
Does not exist.
Sine over cos. So we're gonna rewrite this problem.
So soft.
Okay, now I want you to think about it. We have 2 different ways this can go. We can think that the u is the cos, or we can think that the u is the sine. So you have to think about derivatives and how they work.
Will we get the same answer?
It doesn't work both ways. So you just have to think it through. So the problem is that if you work with the sine, what's the derivative of sine? Cos. But what do we actually have? Do we just have cos up there? No, we've got 1 over cos. Do you guys see that? We've got 1 over cos. So should we use u equals sine? No, we should not. We're going to use u equals cos. U equals cos. Does that make sense how we thought through that? Okay. So even though I know that the derivative of sine is up there, it's not really just plain old cos like I want it to be. It's 1 over cos, and that is not the derivative of sine. Okay. So what's the derivative of cos? Negative sine. So we got negative sine dx. And we don't have that negative there, so we got to divide it by -1.
Good job, James.
Mm-hmm.
Whoa.
That wasn't sarcastic. It was a sincere compliment.
No, it was like.
And so if cos is our u, and we took sine out because that was our derivative, then what are we taking the integral of? 1 over u. Okay. So what is the antiderivative of 1 over u? ln u. So we got a negative in the front, and then we got ln u plus c. And so we've got negative ln of what? Cos x plus c. There we go. So when we were trying to figure out what u is, what's the strategy that we used most often? Did we just jump right into the problem? No, what did we ask ourselves? Yeah, like what's going to come next? Am I going to be able to find the derivative in the problem? And if I can't, then I don't want to use that for my u. Does that make sense? Yes, Ms. Rice? Perfect.
Yes.
Okay, so I know that you guys love the punchline sheets. Oh, it's still recording.